Hello viewers, welcome to my channel. My name is Mr.Adebanjo, and I want to strongly welcome you to this video. In this video we are going to be resolving this triangle to find this side of the triangle. And before we get started, please, if you are yet to subscribe to this channel, please click on the subscribe button on the channel right now, so that whenever we post a video on this channel you will be notified. Also, please comment on the comment section of this video, like the video and share it with students out there who need this resource material to help them in the journey of mathematics. So like I said, we are going to be resolving this triangle in this video. In the previous video you have posted on this channel, we have been resolving triangles, different form of triangles with the knowledge of trigonometric ratio and other aspect of triangles. Now we could also have a scenario whereby we have this type of triangle to resolve in elevation and depression and other application of trigonometric ratio. The angle of elevation of 2 points opposite a vertical wall, or let's say the angle of elevation of of the top of a tower from 2 points opposite the tower is 24 degrees and 37 degrees. I'll come again. The angle of elevation of the top of the tower from the 2 points on the ground is 24 degrees and 37 degrees. If the distance between the 2 points is 43 meters, find the height of the tower. So the angle of elevation of 2 point, or the angle of elevation of the top of a building from 2 points in front of the building is 24 degrees and 37 degrees. You have to, if the distance between the 2 points is 43 meters, find the height of the building or the tower. So these are the question that could result to this type of a triangle. Also we could have let's say we are having two boats in front of a tower, and the angle of the two boats, the angle the two boats make with the horizontal or the top of the sea is 24 degrees and 37 degrees. Then find the, if the distance between the two boats is 43 meters, find the height of the tower. Or two ladders leans against a vertical wall, and the angle the foot of the two ladder make with the ground is 24 degrees and 37 degrees. The distance between the foot of the two ladder is 43 meters. Find the height of the wall. So there are different scenarios that could lead to this type of diagram. The issue is that when we now sketch the diagram, how do we resolve such triangle? If we look at this now critically, we are having a big right angle triangle. This triangle is a big right angle triangle, and inside it we are having another right angle triangle, which is this triangle here. It's another right angle triangle, but this triangle is not a right angle triangle. So every if you look at this the big right angle triangle, we are not giving any side. No side is given, and inside this small right angle triangle as well, no side is given as well, aside from the distance given from here to here, which is 43 meters. Then how do we resolve this type of triangle? How do you find this height in this kind of a triangle given? You may ask yourself this question before we solve it together. How do we resolve by finding the height of this side of the triangle given only from here to here of the triangle? How can we do that? It's quite simple, and but I just want you to reason with me. I want you to reason with me before we solve it together. Just pause the video for a second. So how do you think we can resolve this kind of triangle? You are looking for this side of the triangle. Another question can say you should find from here to here, or this side as well. Or it's possible you also find the whole side of this, yeah, from here to here, or you have to find from here to here. It could be any side you have to find, but the fact remains that if you're able to know this side, then you can find any side of the triangle, whether the small one or the big one. Now, without wasting much of our time, if from here to here is 43, so we can call from here to here a variable. So let's call from here to here to be what, x. So that means this small right angle triangle we have here, we know that this side is what, x, and this side is what, h. So if from here to here is x, that means you can know the full length from here to here. What would that be? If from here to here is x, what will be from here to here, the full length of this triangle, the full base rather, the full base of the big rectangle triangle, what will it be? If here is x, that will be x plus 43. So from here to here will be x plus 43. So, and that's what we are having in this diagram right now, that if you call from here to here x, technically from here to here will be 34 plus x, which I believe you understand. So now for this big triangle, which is a right angle triangle, we have this side given to be 34, we have this side to be 34 plus x. For the small right angle triangle we have here, this side will be x. So we can use that to find to solve what we are looking for, because this side we are looking for is shared by this small triangle and the big triangle as well. So that is this small right angle triangle here has this side, and this big right angle triangle also have this side. So they are both sharing this side of the triangle. So technically we can use that to find what you are looking for. How? From this small triangle, from this small right angle triangle here, from this one here, we can use what's the relationship between this angle 37 degrees, this side and this side of the triangle. That is tan. Tan is opposite over what, adjacent. Opposite over of angle 37 degrees. 37 degrees is this side, which is h, and this side is what, the adjacent, which is x. So tan 37 will give us h over x. From there we can make h sort of the formula. So if we have h is equals to, if you cross multiply, x times tan 37, which you can call equation 1. Also from the big triangle, which is also a right angle triangle, from this big right angle triangle here, can we see? Then this angle here belongs to that big triangle. So angle 24 degrees here belongs to this big right angle triangle. So what relationship between this angle 24 degrees, this side of the triangle, and the full base here? That's also tan. Tan is opposite over adjacent. So tan 24 degrees also will give us this side, which is h, over the base, which is 34 plus x. From there also we can make h subject to the formula. So you'll be having h equals to, if you cross multiply, you're having 34 plus x multiplied by tan 24, which you can call equation 2. We can now resolve these two equations to find the value of our x, because h is equal to this, h is also equal to this, so that means this will be equal to this as well. So from there you will be having x tan 37, which is x tan 37 here, to be equal to 34 plus x tan 24, which is this. I hope you understand that. Then from there you can simplify further. Tan 24 will open the bracket. Tan 24 times 34 will give us 34 times 24. Then plus 24 times s will give us s tan 24. Then from there, you can press your calculator for this and this as well. Tan 37 will give us 0.7536 times x will give us 0.7536x equals to, you can press your calculator, tan 34 tan 24 will give us 15.14 plus tan 24 is 0.4452 times s will give us 0.44552x. From there you can collect like times, this one comes here, you'll be having 0.7536x minus 0.4452x equals to 15.14. From there we can subtract this from this, 0.753 minus 0.4452, that will give us 0.3084x. Or you can just factorize x out here. If you factorize x out here, you're having x into 0.7536 minus 0.4452, close the bracket. If you subtract the what you have inside the bracket, you'll be having 0.3084 times s, which is going to give us 0.3084x equals to 15.14. Our aim is to find x. If you divide both sides by 0.3084, that means be having your x to be equal to 15.14 divided by 0.3084, and that should give us 49.09 meter as the value of our s, which if you approximate to the nearest meter, that should give us 49 meter approximately. So let's go back. Now we know from year to year to be that 49. So we know our from year to year to be 49. That means we can know the length, the full length of the base. That will be 34 plus 49. So that should give us the full length of the base. I hope you understand that now. Then our aim is to find this h, which is this side of the triangle. So you can use, since we know the value of our x, you can put the value here to find the value of our h, or you can do that here as well. So let's go back. Now we record that from the equation 1, we have h to be equal to x tan 37. So we know the value of our s now to be 49.09 times tan 37. If you punch your calculator, you'll be given 36.99 meter, which if you approximate to the nearest meter, give us 37 meter approximately as the value of our h, as the height of the triangle. So let's go back quickly. So now we know that we know the value of our h now. Now that you know the value of our h, the question can see, and we know the value of this side as well. If the question asks us to find this side of the triangle, now I believe we can do that, since we have these two sides given to us in this triangle now, or we now know this side and this side. So you can use Pythagoras theorem or trigonometric ratio to still find this side. Also, if you have to find this side of the big triangle, also we can do that using the big triangle, which is also a right angle triangle, because this side is this angle is a right angle. So we can also, since we know the full length here, 34 plus the value of our x that we got, then we can know this side, and we also know this side. You can also use Pythagoras theorem to find this side of the triangle, or you still use trigonometric ratio. So I hope you understand how we resolve that triangle. So it's quite simple, and then in future video we're going to be giving you more questions that is related to trigonometric ratio and how we could resolve those triangle. I hope you have been able to learn one or two things on the from this video. So if you understand this, please give it a thumb up, comment, and share the video with the student out there who need this resource material. And if you are yet to subscribe to the channel, please click on the subscribe button right now so that you will be notified whenever we post information on this platform. And thank you, and God bless you as you do so.